Hello students, as you know, we are doing a very interesting chapter that is sets. So are you ready to learn something new and more interesting? Let's start. If set A is 1, then subsets of set A are set 1 and 5. It means number of subsets are 2. If set A is 2, 3, then subsets of set A are set 2, 3, 2, 3, and 5. Because 5 is the subset of every set. It means number of subsets are 4. If set A is 1, 2, 3, then subsets of set A are 1, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 3, and 5. It means number of subsets are 8. Here we have only one element, therefore number of subsets are 2 to the power 1. Here we have two elements, so number of subsets are 2 to the power 4, it means 2 to the power 2, it means 4. Here number of elements are 3, it means number of subsets are 2 to the power 3 is equal to 8. So in this way we can say number of subsets in any set is equal to 2 to the power n, where n is the number of elements in that particular set. Now, set A is 1, 2. Subsets of set A are 1, 2, 1, 2, and 5. Now, the collection of all subsets of set A is called the power set of A. It means if we make a single set of all subsets of set A, then this set is called power set of A. And number of elements in power set of A is equal to 1, 2, 3, and 4. Now, what is a universal set? Universal set is something similar to universe. As universe contains everything, we can say universal set also contains everything. Now, what do we mean by everything? Let's take one example. Set A is 1, 2. Set B is 3, 5. Set C is 1, 5, 7. Then what will be the universal set of these three sets? Now, universal set is always denoted by capital letter U. Now, universal set must contain all these elements 1, 2, 3, 5, 7. And it also have some extra elements. Extra elements may be or may not be present in universal set. Let's take one more example. If Set A is the set of students of class 11th A. Set B is set of students of class 11th B. Now what will be the universal set of these two sets? We can say universal set is set of students of class 11th, because this set must contain all the students of 11th A and 11th B. Also, this set can have some students of some other sections like 11th C, 11th D and so on. So, universal set of any sets must contain all the elements of these sets. Now, this is the number line 0, 1, 2, 3, minus 1, minus 2. This is positive x, negative x. If any number, any real number lies between 1, 2, 3, but not including 1 and 3, then we can write it as 1, 3 in open interval. These brackets represent an open interval. It means all real numbers between 1 and 3, but 1 and 3 are not included. In set form, we can write it as x lies between 1 to 3 and x belongs to R. Now, if we have number which lies between 1 to 3 and also included 1 and 3, then we can write it as close interval 1 to 3. It means all real numbers between 1 and 3, also including 1 and 3. So we can write it as x lies between 1 and 3 with equal sign and x belongs to R. So if we use this bracket, it means we are using open interval, and if we are using this bracket, it means we are talking about close interval. Now, if we have open interval 1 and close interval 3, it means all real numbers between 1 and 3, but 1 is not included and 3 is included. If we have close interval 1 and open interval 3, it means all real numbers between 1 and 3, including 1 but excluding 3. So this bracket means open interval, this bracket means close interval. So in this way, we can represent any set in close interval and in open interval for real numbers. Now, what is the complement of a set? Let universal set is 1, 2, 3, 4, 5. Set A is 2, 3. Set B is 4, 5. C is 1, 3, 4. Now, what is the complement of set A? For complement, we can write it as A, complement by symbol C, or we can write A dash. So what is A dash or A complement? We have to write all the elements of universal set, but we have to leave the elements which are present in set A. So we will write 1, 4 and 5, because in set A we have elements 2 and 3. Now what is B complement? Now again we have to write the elements of universal set, but we have to leave the elements of set B. So leave 4, 5, we can write 1, 2, 3. So B complement is 1, 2, 3. Now C complement. It means C complement is 2, 5. Now here we have A complement is 1, 4, 5. Now let B is equal to A dash, that is 1, 4, 5. Now what's about D dash, or we can say complement of D, or we can say A complement whole complement. Now again we have to write the elements of universal set, and we have to leave the elements of set D. It means we will write 2, 3, because in set D 1, 4, 5 are present. So we have to leave for D complement. So D complement is 2, 3. Now we will discuss some properties of the operation of union. First one is A union B is equal to B union A. This is commutative law. For example, set A is 1, 2, set B is 3, 4. Now, A union B is 1, 2, 3, 4. Also, B union A is 3, 4, 1, 2. And in sets, order doesn't matter. We can write it as 1, 2, 3, 4. It means A union B is equal to B union A. Second property is, or we can say second law is associative law. A union B union C is equal to A union B union C. This is associative law. Now, third property is A union phi is equal to A. If set A is 1, 2, phi means empty set, then A union phi is again 1, 2. So it means A. This is called law of identity element. Law of identity element. And phi is the identity element. Now next law is A union A is equal to A. If set A is 1, 2, then A union A means we have to write the elements of A, and again A, it means 1, 2. So it is equal to A, and this is called idempotent law. This is called idempotent law. Now, next one is universal set union A. If universal set is 1, 2, 3 and A is 1, 2, then universal set union A is 1, 2, 3. It means again universal set. This is law of union. So these are the properties of operation of union. Now let's discuss some properties of operation of intersection. First one is A intersection B is equal to B intersection A. This is commutative law. For example, A is 1, 2, 3, B is 2, 5. Then what is A intersection B? Intersection means common element. So 2 is the common element. Therefore, A intersection B is 2. Now, B intersection A. Again, B intersection A means common element. So here we have 2 as common element. So B intersection A is also set 2. Therefore, A intersection B is equal to B intersection A. This is commutative law. Second, A intersection B intersection C is equal to A intersection B intersection C. This is associative law. Let's set A is 1, 2, set B is 2, 3, and set C is 1, 3, 4. Now, at first we will solve left hand side. A intersection B is equal to 2. Now, A intersection B intersection C. Nothing is common in these two. So, result is 5. Now, on right hand side, A intersection B intersection C. So, at first we will solve B intersection C. B intersection C is set 3. Now, A intersection B intersection C. Now, nothing is common in these two sets. So, result is 5. It means this left hand side is equal to right hand side. Therefore, this result is equal to this. It means associative law.
Groceries! Come and get your groceries! I've got veggies, fruits, bread, you name it.
Hi, did you say you have groceries?
Yes. Here you go.
Well, how much is it? My dad and I don't have much money.
Don't worry about it. It's free of charge.
Wow, really? Thank you so much. My dad's gonna be so happy.
You're welcome. Free groceries!
Free groceries? Come on. What's the catch?
Oh, there is no catch. A lot of people are hurting in the world right now, and you never know. One small act of kindness can make a big difference. So, here you go.
Look, I hate to break it to you, but do you really think that giving someone a bag of groceries is gonna make a difference?
Well, I do, because it's made a difference in my life. You see, a couple months ago, I opened up a letter from my employer. Because of the hard times, there wasn't enough work, so they fired me. I had no idea how I was going to get by. Bills quickly began piling up. I didn't even know how I was going to survive. Things got so bad that I even ran out of food and had nothing to eat. I scraped up all the money I could find, and I still didn't have enough to buy groceries. But then, out of nowhere, a kind man came and handed me a bag full of food. It was as if an angel came down to help me. So you see, I never would have eaten if it wasn't for that man. His one small act of kindness made a really big difference in my life. So now that I have a new job, I want to help others too.
Well, that is a sweet story and all. But there are millions of people out there that are hungry. So again, I hate to break it to you, but you giving away free groceries isn't gonna make a difference.
Excuse me, ma'am. Are you the woman who gave my son groceries?
Hi, yes, I am. Why, is everything okay?
It's more than okay. You see, I was recently let go from work, and things have been so hard I wasn't sure if I was going to be able to feed my family today. Then my son walked in with a bag of groceries that you gave to him, and now my family can eat today. So thank you. From the bottom of our hearts, thank you so much.
You're welcome. And actually, take this too. You might need it.
I won't forget this. God bless you.
God bless you too. Well, it made a difference for them.
Wow. Now that I've seen it with my own eyes, I have to admit you were right. I'm so sorry for the way I treated you earlier.
It's okay. Would you like a bag of groceries? Free of charge.
Sure. Thank you.
You're welcome. Have a nice day.
You too.
Groceries! How we get you free groceries?
Hi. Did you say you have groceries?
Sure, yes.
Oh, well, how much are they? It's just that things have been a little hard lately with...
Don't worry about it. They're free of charge.
Really? Oh my god. You have no idea how much this means to me. But why are you doing this?
Well, somebody once told me, a small act of kindness can make a big difference.
Wow. Thank you so much.
Groceries! Get your free groceries!
Hey Dhar Mann fam, I hope you love that message. Please remember, we're not just telling stories, we're changing lives. And when you share my videos, you're helping to change lives too. I appreciate you, and I'll see you in the next video.
Now the next one is phi intersection A is equal to phi and universal set intersection A is equal to A. These are the law of union and phi. This is the law of phi and this is the law of union. Now, phi means empty set. Let A is 1, 2. Nothing is common. So phi intersection A is again empty set. Now, universal set is 1, 2, 3. A is 1, 2. Because universal set must contain all the elements of set A. Therefore, universal set intersection A is equal to 1, 2, it means again A. So it means phi intersection A is always phi, and universal set intersection with any set is always that set. Now next is A intersection A is always equal to A. Let set A is 1, 2. Now what is A intersection A? It means 1, 2 intersection 1, 2. Intersection means common element. All elements are common. So again result is set A. So A intersection A is always equal to A. This is idempotent law. And the last but not the least, A intersection B union C is equal to A intersection B union A intersection C. This is distributive law. Here, intersection is distributed over union. Intersection is distributive over addition. For example, if we have one, 2 as an element of set A, B set is 2, 3, set C is 2, 4. Now, on left hand side, B union C is 2, 3, 4. And A intersection B union C means common in these two sets. So result is 2. Now, right hand side, A intersection B 2, only common element is 2. Now A intersection C 2. Now take union of these two sets, A intersection B union A intersection C. Union means we have to write all the elements of both sets. So here we have 2. So result is again 2. So left hand side is equal to right hand side. So A intersection B union C is equal to A intersection B union A intersection C. This is distributive law. That's all for today. Thank you all.